Hey everyone, welcome to Math 103. We're working on section 2.3 today on translating descriptions in words into mathematical expressions. Take a look at the first page of the handout. On the left-hand side, you've got all the operations: addition, subtraction, multiplication, division, and powers. And to the right of that are some keywords associated with those operations. So for example, addition, you got things like more than, the total of, plus. Now, the nice thing about addition is the order doesn't matter. So when we translate 8 more than W, we can write that as W plus 8, starting with W and adding 8 to it, or 8 plus W, and it doesn't affect the expression in the end. The situation becomes a little bit more complex when we get to subtraction, because with subtraction, order does matter. So for example, less than, we say 12 less than B. We're starting with B, and we're removing 12 from it, so that's B minus 12. Same thing with subtracted from. P subtracted from 12. We're starting with 12 and removing P from it, so 12 minus P. So compare that with the difference between. The difference between x and 1, that's translated as x minus 1. So the order that the variables or numbers are presented in the description is the same as the expression. Now multiplication, that's also commutative, just like addition. So order doesn't matter with multiplication either. So negative 2 times c, that's just negative 2c, just multiply them together in order. The product of x and y, x times y, but we could also flip that around to be y times x. It means the same thing. Division, here's another one where order does matter, but the nice thing about division is whatever order they're given in the description, they result in the same order in the fraction. So v divided by 15, that's the first thing is on top, so v is on top. 15 is the second thing, so that's on the bottom. Same thing with quotient or ratio. The ratio of x to 7, the first thing x is on top. Second thing mentioned, 7 is on the bottom. So the only ones that flip the order are the first two in the subtraction. And then powers, the square of, that's to the second power. Cube, that's to the third power. And anything beyond cube, they'll just say something like the fifth power of a, or a to the fifth power. So you will need to know these by sight and be able to translate them. So some advice for studying this sort of thing, what you should do is make one flashcard for each operation and then just put the keywords on the back. Then you can cycle through those and learn the keywords. I recommend also, instead of just looking at them, that's a good thing to do in the beginning, but after you start to learn them, start writing them out. That way, you're engaging two different things. You're engaging your mind and your body at the same time, and you get what's called muscle memory, just from the act of writing it out. It helps to remember. So what we're going to do is we're going to start out by translating what's known as simple expressions. And a simple expression is made up of two numbers or variables and one operation. You cannot have two operations in a simple expression. A simple expression only has one. So first thing we're going to do is learn to translate these simple expressions. So that brings us to your turn number 1. Use the information on the table to translate those simple expressions into mathematical expressions. And just a reminder, when we get to your turns, go ahead and pause the video and work through your turns, and because I'm not going to pause, I'm just going to go right to the answers. First one, the ratio of 6 and y. Ratio means division, so that is 6 divided by y. Part B, the difference between 8 and x. Difference is subtraction. 8's given first, so that's 8. X is second, 8 minus x. Part C, b increased by 12. Increased by is addition, so that's b plus 12. 2/3 of z. Anytime you want to take a fraction of something, that's multiplication, so 2/3 times z. So you can write it like that. You can write it without the dot, 2/3 z. And you can also write it 2z, z in the numerator, over 3. You cannot write it with z in the denominator. E, the cube of r. Cube is third exponent, so r to the third. 2 more than n. Starting with n and adding 2 to it, n plus 2. Fourth power of m, another exponent, so m to the fourth. For g, h, 4 less than v. All right, this one's a little trickier because we have to reverse the order. So we're starting with v and we're removing 4 from it, so v minus 4. I, the product of 3 and d. Product is multiplication, so that's 3d. And j, the quotient of 5 and c. Quotient is division, so that is 5 is the first thing in the description. Second thing given is c, so that goes in the denominator. 5 over c. Now we're going to translate compound expressions. And compound expressions have more than one operation in them. So there's a strategy we can use to translate these, involving only translating simple expressions, or things that are just like simple expressions. So what we're going to do is look through this phrase here and find the simple expression first. So what I usually do is start from the left and see if that's going to work. We'll go 3 less than, so we've got a number and one operation. Less than indicates subtraction. Now we'll keep going. The product, well, we just hit our second operation. Remember, we got subtraction, now we have multiplication. So you can't have 2 operations in a simple expression, so that's not where we're going to start. Instead, let's start here, the product of x and y. This is a simple expression because we have one operation, product, multiplication, and 2 numbers of variables, x and y. So we'll start by translating that. The product of x and y is x times y. Now it's a good idea in the beginning to rewrite the sentence replacing the phrase with its expression. So that would be 3 less than and then instead of the product of x and y, we'll just write xy. And now we'll translate this. And this is very similar to a simple expression if we consider this to be one thing. Then we've got one number here, and we'll just call this a variable here. So, and one operation in between, less than. So 3 less than xy, we're starting with xy, and we're removing 3 from it. So that is xy minus 3. Now some of these early ones, you may be able to just translate them straight off just by looking at them. I recommend going through this process because when we get to the more difficult ones, most people really need to use this process. Your turn, number 2. So let's start by finding the simple expression in these compound expressions. And just underline it, and then we'll go ahead and translate in a moment. First one, product of y and z squared. Well, if we start at the beginning, we've got multiplication, and by the time we get to another variable, we've got another operation here, z squared. So we've got power here and product. So we don't want to start there. We want to start with the simplest thing we can translate, and that would be z squared. Now this one, it's a little tricky because I know we're looking for two numbers and our variables, but z squared is z times z. So there's your two variables. They just happen to be the same one. So there's the simple expression that we would start with in that one. Second one, the sum of 2 times y and 3. Well, if we start here, we got sum and we have times, addition, multiplication. So that's two operations, so we can't start there. But if we start here, 2 times y, there's your simple expression. Two numbers of variables, 2 and y, and the operation times. Next up, 2 more than the quotient of x and y. So the simple expression here, the quotient of x and y. One operation, division, two numbers or variables. The difference between 12 and the product of x and 2. The simple expression here is the product of x and 2. One operation, multiplication, x and 2, two numbers or variables. All right, next up, your turn number 3. Now that we've found the simple expression to start with, use this 4-step process to translate these. Start by translating the simple expression for each one. Rewrite the sentence, replacing the simple expression with its translation, and then translate that sentence, and that's the last step. All right, first one, z squared. So I'll write the sentence, the product of y and z squared. And now we can translate this. Product is multiplication. We're going to multiply y and z squared. So that's y times z squared. Next up, the sum of 2 times y and 3. So 2 times y times is multiplication, so that translates into 2y. Now we can rewrite this one. Replacing 2 times y with 2y, so the sum of 2y and 3. Sum is addition, so this is 2y plus 3. 2 more than the quotient of x and y. Quotient is division, so we'll divide x by y. Rewriting this, we've got 2 more then. X over y. More than is addition, so we're starting with x divided by y, and we want 2 more than that. So x over y plus 2. The product of x and 2, for these, since we know that multiplication is commutative, usually you write the coefficient first and then the variable, so that can be translated as 2x. Now we want the difference between, I'm just going to abbreviate here, difference between 12 and 2x. So difference is subtraction, so this would be 12 minus 2x. You please read through, including parentheses. Now we're going to translate this phrase, the product of 3 and the sum of x and 7. So we'll start just like we did before by finding the simple expression. All right, here's our one operation and two numbers or variables. So the sum of x and 7. Sum is addition, so that translates into x plus 7. Now we need to translate the product of 3 and x plus 7. Now before I said we have to consider this expression to be one thing. Now we're going to multiply by something. So we have to put this thing in parentheses to make it one thing. Now when we multiply, we're going to multiply 3 by the entire thing since it's inside parentheses. So it is 3 times x plus 7. Now let's say we did not put the parentheses in there. And we just multiplied 3 times x plus 7. If we translate this, well, we're going to do this in reverse now. The first step would be the sum of 3x and 7. Then we need to break this thing up into the sum of the product of 3 and x and 7. And that does not match what we started with. So this would be an incorrect translation of what we started with. All right, next up, we're going to compare two very similarly worded phrases. So the simple expression has already been underlined. Go ahead and complete the 4-step process for both of these. Now both of these descriptions have nearly identical words. They're just it's a little bit different order. As you can see, we come up with two very different expressions because if we distribute into these parentheses, we get 4x plus 28 instead of 4x plus 7 on the right. Your turn number 4. For these, you're going to go through the entire process on your own. Start by identifying the simple expression, translate that, rewrite the sentence, and then do your final translation. All right, the simple expression in the first one, the product of x and y. So that gives us xy. For b, the ratio of the sum of 3 and z and 8. The simple expression is the sum of 3 and z. Sum is addition, so that translates into 3 plus z. Now if you rewrite these sentences, now we're going to translate the difference between 7 and xy. Difference is subtraction, so that gives us 7 minus xy. And for this one, ratio is division. So the first thing, this entire expression 3 plus c goes on top. And the second thing, 8 goes on the bottom. So 3 plus z divided by 8. This lesson was originally designed to be a group activity. Now if you have something to work with, I recommend doing what's on the back, the create your own expression part. Other than that, that's it for today. Hope you all have a great day.